Last video for today, rational exponents. What do we do if we're tasked with finding the derivative of the cube root of x squared? Now, in a case like this, there is no radical rule. We got a power rule, we got a sum difference rule, but we don't have a radical rule. However, because we have the power rule, we can take this, and like our negative exponents, we can turn this into a power rule situation. Going back to algebra class, we know that radicals can be rewritten as rational exponents. That means we're going to have a fraction in our exponent. The question is, what number goes where? Well, if you recall, the exponent which belongs to the variable will end up in the numerator. And the root that we are taking, in this case it's the third root, ends up in the denominator. So the cube root of x squared is the same thing as x to the 2/3. This we do not have a derivative rule for. But this one we do. So let's do that. Let's take the derivative. Well, we know that power rule says place the exponent out front. So we got 2/3. Our variable is x. And we have to subtract 1 from 2/3. Now, 2/3 minus 1, well, we know that whenever we want to add or subtract something with a fraction, we need a common denominator. Known that for years. So we're going to make this 1 into 3/3. 2/3 minus 3/3 is negative 1/3. And that number is our new exponent. Now this answer is entirely correct, but we do want to be prepared to rewrite this so that way we could use the derivative or plug a number into the derivative. So just be ready to take this derivative and rewrite it so that there's no longer a negative exponent, nor is there a rational exponent. So we're going to have 2 over 3. Now, x to the negative 1/3 becomes x to the positive 1/3 if we move that x to the 1/3 down into the denominator. And we can do the reverse of what we did up here, which is we can turn this back into a radical. So we're going to have 2 over 3. Our denominator of our exponent is a 3, so that means we're taking the cube root. And the numerator of our exponent is 1. So that's the cube root of x. Okay, now, why are we doing this? Well, because you might be charged with finding g prime evaluated at 8. Give myself a little space there. All right, well, g prime evaluated at 8, yeah, that would be 2 over 3 times 8 to the negative 1/3. But do you know what 8 to the negative 1/3 is without a calculator off the top of your head? Probably not. However, if we plug 8 in here, then we have 2 over 3 times the cube root of 8. Well, now your brain says cube root of 8, what number times itself again is 8? Oh, it's 2. So we have 2 over 3 times 2, or 2/6, or a final answer of 1/3. So the moral of the story is, yes, this is a correct derivative, as is this one right here. And those would get you full credit in an open response section of the exam. However, you do want to be prepared to go from either one of these to this right here. Because on a multiple choice question, this may be the only option of the 3 that you see as a possible answer.